Hello again. This is Math 2231 coming to you from the College of DuPage, and the title of this lecture is One Derivation of Herron's Formula. As always, please be an attentive learner while watching this video, perhaps with pencil and paper in hand and pausing from time to time. Recall that Herron's formula says that if a triangle has sides A, B, and C, as shown here, with lengths A, B, and C as shown here, and the semi-perimeter being half of adding up the sides, and we call that S. So the S is the semi-perimeter. Then the area of the triangle, script A, can be given by the formula script A is equal to the square root of S times S minus A times S minus B times S minus C. Now we're going to prove this formula using some significant trigonometry to enhance our review of trigonometry. But let's start in the following way. Let triangle ABC, and these refer to the vertices, these are capital A, capital B, capital C, and the convention is the sides opposite angles A, B, and C respectively have lengths A, B, and C lowercase respectively. And if we apply to this triangle the cosine law, this is a statement of the cosine law. But I can solve this equation for the cosine of A, and this is what I get solving that equation for cosine of A. And this is what we'll refer to as equation 1, and later on I'll say, oh, look at equation 1. So pause here for a moment, and then we will go and talk about the perimeter of the triangle is given by A plus B plus C. So half of the perimeter is S is equal to 1/2 A plus B plus C. We're calling this equation 2. And if we multiply both sides by 2, we get 2S equals A plus B plus C. And now we can subtract 2a from both sides. Now if we subtract 2a from 2s, we get 2a minus 2s. And we subtract 2a from a plus b plus c, we get b plus c. But then we have a minus 2a gives us a negative a. And we can factor the 2 out of this side, and we have 2 times s minus a. The 2 times the whole of s minus a is equal to this by factoring. Now we can go up to this equation again, which we called 3, and if we were to subtract 2b and 2c and mimic the steps, and I encourage a serious student to actually do this in a similar way, we can get equations 5 and 6, which tell us that a minus b plus c is 2 times the whole of s minus b, and a plus b minus c is 2 times the whole of s minus c. Again, we're going to use all of these equations, so a serious student would want to keep track of the numbered equations. Now we're going to talk about getting an expression for 1 minus cosine A. Now previously we talked about the cosine law, so the 1 just sits there, but we're subtracting cosine A, which we previously solved for in equation 1. So we're replacing cosine A with this, and notice that the minus sign is there. And now we're going to get a common denominator. The common denominator is going to be 2b plus c. So in the 1, we have to multiply top and bottom by 2b, and then we have this. Now notice that you have to be careful about the signs, because a minus gives you a plus a squared, and a minus b squared and a minus c squared. So those are the signs. And then what we can do is we can say that this is a squared. And then I have minus factoring out here, and so you see the signs. This is the same as a squared minus parentheses b squared minus 2bc plus c squared, which actually is, when you factor it, it is b minus c whole squared. And since you have a squared minus b minus c whole squared, this is like x squared minus y squared, and it can be factored into x minus y times x plus y. So we factor this as a difference of squares, and we distribute the signs, and we have that this is a minus b plus c, a minus times a minus. This is a plus b minus c. But this is the same thing as 2s minus b from equation 5 and equation 6. This is the same thing as 2s minus c over 2bc. I can cancel the 2's if I want to. Actually, let's don't cancel the 2's yet. You could cancel the 2's, but let's don't cancel the 2's yet. So now way up here I had 1 minus cosine of a. I did all this work and I got it's this. So 1 minus cosine a is this. Now similarly, it can be shown that 1 plus cosine a, again using the same kind of arithmetic, is 2s times s minus a divided by bc. Again, the serious student would go through these steps and prove that themselves. Now we're going to use the very important trig identities for the cosine of 2 theta. Recall that the cosine of 2 theta is, we have many identities for that, but the cosine of 2 theta is 2 cosine squared theta minus 1, and it's also 1 minus 2 sine squared theta minus 1. We use both of these in calculus 1 and calculus 2 and beyond. So we're going to apply this general formula here, but we're going to apply this to theta being a over 2. So 2 times a over 2 is cosine of a is 2 cosine squared a over 2 minus 1. So we're going to add 1 to both sides, and we get 1 plus cosine a is equal to 2 cosine squared a over 2. But now we're going to substitute from the equation we called 8. And we have that this is our equation. We can now divide both sides by 2 and get cosine squared a over 2 is equal to s times s minus a over bc. And if we take the square root, we get here what we're going to call equation 9, which is cosine a over 2 equals the square root of s times s minus a divided by bc. We're going to do a similar thing over here to get an expression for it, sine a over 2. Let's talk about that. This was the general trig identity. Again, we're letting theta equal a over 2. So the cosine of a is equal to 1 minus 2 sine squared a over 2. We're going to subtract this from 1. And when you subtract a minus times a minus, so we get 1 minus cosine a is equal to 2 sine squared a over 2. Now we're going to use 7 this time, so we're going to be substituting 7 for 1 minus cosine a. We get this expression and we cancel the 2's. Here is where we cancel the 2's. And then we're going to take the square root of both sides. So we have the sine of a over 2 is equal to the square root of s minus b times s minus c all over bc, and we call this 10. Now we're going to be using 9 and 10 very soon. Now the area of a triangle can be found that the area of the triangle is 1/2 BC times sine of A. And you know that from your trig, but you also know that if I draw my generic triangle here and drop a perpendicular from B down to the side, well, I know that the area of a triangle is 1/2 the base times the height. Now here the base is B. A is the angle in between, and in this side here, this is a 90-degree angle, so this side here is going to be the sine of A times C. So 1/2 the base, that's 1/2 of B, times the height, which is going to be C times sine of A, is 1/2 the base times the height. So the area is 1/2 BC sine of A. So if we multiply both sides by 2 and solve for sine of A, we get sine of A is 2 the area over BC. We just solve for the sine of A. But now we're going to recall the double angle formula for sine of 2 theta. The sine of 2 theta is 2 times the sine of theta, cosine of theta. And so the sine of A, letting A over 2 equal theta. So the sine of A is 2 times the sine of A over 2 times the cosine of A over 2. So we're going to be doing then some substitution for sine of A up here. So we have 2 sine of B. Here's where the sine of A was, but we're substituting what sine of A is. So 2 times the area divided by BC is 2 sine of A over 2 times cosine of A over 2. But now we have expressions for these, and so 2a over bc is equal to, we're going to use the equations 9 and 10 that we have. So this is red, and this is the green substitution. And now you have radicals. We can multiply the radicals together. So we're going to get s times s minus a times s minus b times s minus c all over. And this is the square root of b squared, c squared. But then I'm going to multiply both sides by bc and divides both sides by 2. And I end up with Herron's formula. There's another part to the problem I asked you, but that's mostly plugging in numbers, so I'm not going to include that on the video. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself, because self-care is important, and of each other. We're all in this together. God bless you all.